Hey there folks, welcome back to another part of my thing where I am making a Tetris data extractor. I got some new equipment today, so hopefully things work out. Anyway, let's get started. I think we were in Windows last time, so let's do that. There are a few ways we could go today. The problems that we've been facing lately are we did a bunch of tests. We tried to refactor our algorithm, found that it didn't work, went back in time to write tests for our working algorithm, and found some issues with the working algorithm, a few. But my goal is to refactor, but I still have a few outstanding issues before the refactor. But I know after the refactor, it totally destroyed everything. So whether we should focus on the few errors that we were getting with the original algorithm, or if we should just go out and refactor and then fix things after the fact. And I think what we're going to do is probably fix our algorithm. Fix the issues we were having with the original algorithm, because I wasn't finished the refactor yet, and I want to try and do more refactoring. And so let's just see what we can do to fix our original issues, and then we'll move on when we're comfortable. Because I'm really going back in time and doing something I should have done first. That is, write tests for the algorithm before we refactor it. So, my fault. But anyway, this is what we had last time. We had a whole bunch of these screenshots right here. All these screenshots. We had integration test 2, integration test 3, all these screenshots. They're all screenshots of Tetris screens. And we were reading them all. And these are the issues that we found out of all of them. And most of them are all of them are piece counts. The Z found 9, but expected 8. And so the good thing about this, we noted last time, is there's all the scores were correctly read, all the line counts were correctly read, and the level was correctly read. And those are the most important. But these piece counts are kind of nice too. And it looks like we have some issues mistaking 9s for 8s, or mistaking 8s for 9s. Mistaking 8s for 6s, and mistaking 7s for 2s. Not surprising, 7s and 2s, because the 2 really is the shape of a 7, just with another tail at the end. But let's dive into these things. I'm interested in this 2 and 7, so let's find out where that was happening here. In screenshot 205, well, actually in 105 and 109. So we've actually got 3 instances where we've mistaken a 7 for a 2. So let's try and fix one, and hopefully the others will get fixed. All right, so let's open, actually 105 has 2 errors. We'll definitely use 105 then. So let's go back to our tests, and we are going to make sure all test cases. For each line and line, skip 1 where x dot starts with 105.png. We are just looking at this one. That's all we care about. So instead of running them all, let's just run 105. Okay, and this was our test. We're going to get the data, open the file, send it in, and just see if our test case matches our actual data. And just to remind ourselves, this is the CSV file we made. So 105, we've gone and we've, you know, let's just open up 105, because I guess it's possible I could have entered the data in wrong. 105. This is the screenshot in question. So the Z was read as 9, but we entered 8. Okay, that's that's awesome. I thought that was an error. Look, this screenshot is absolutely a 9. 9 Zs. Yes, I'm Canadian. It's Z. Z expected 9, but... Oh, I keep messing myself up. No. We expected it to be a 9, but we found an 8. Okay. And we expected 12, but we thought 17 S's. And this is an S. We expected 12, but found 17. Okay, so this is 9 and 12, but we read 8 and 17. Okay, that's fine. Okay, let's first look at the, well, we'll start at the top, the Z. So let's go to our test. We are now just running this for 105. Let us run it for just the Z. So we're gonna comment this stuff out. And we're going to comment this stuff out. Okay. Oh, actually, that doesn't matter. We're not running it. We know what we're expecting. We know what it's going to do. Anyway, okay, I'm going to put a breakpoint here, and let's get all this data. Okay, let's begin. We'll do that by debugging this test, and here we go. We're going to be interested in the Zs. All right, we'll step into get all data. And let's run to here. I can't really run to there, can I? Okay, let's put a breakpoint at Z. Okay, we'll try it again. Just hit continue here. There we go. So we've got the screenshot, we've got all this stuff, and now we're going to go into here, into the Z piece, the crop area, and the sub image. So like before, we're going to take the sub image dot save. I don't think you could see that, but we're going to save it, and we're going to go into our I can't think. I'm having a very difficult time thinking today. This one, this one, this one, this one. Okay, do I have my test? Yes. So this is the sub-image of what we're looking for. Excuse me. Okay, that looks right. Now we're going to split it up to each digit. It correctly determines a 0. And it correctly determines another 0. And now this is where we get our error. So we're going to get our digit image. Now instead of sub-image, let's go ahead and save. Close all these. Instead of sub-image, we'll go digit image. Okay, that's been evaluated. So this is the thing in question. And already, I mean, I think there's an issue here because we got a lot of stuff on this side. And we seem to have cut the 9 off. So let's go into the algorithm. And that's the thing, when we reduce the image, and remember the image reduced is all of the black stuff around it has been eliminated. That's what we call reducing it. That's what I call reducing it. So I can actually save this, and I'm always saving it to the same file. That's okay. It just overwrites it. So this is the 9 after it's been reduced. I can already tell why this is being mistaken for an 8. It's really, really quite difficult. Like, as a human being, I can see a 9 in that shape. But I'm curious what the difference between the 9 and the 8 is. So if we go into here, we're going to build up the probability list. And if you don't remember, we basically get the probability that the digit we're looking at is the digit 0. We come up with a number, and then we go through each of the 10 digits, and we just pick the highest one. And so our probability score for 0 is 82. Then we move on to the 1. And our probability score for 1 is minus 47. So that's definitely not it. Then we go to 2, and we get minus 11. So far 0 is the winner. 34 with 3. 3 is part of an 8, so I mean 3 is most likely. Here, we can see that there. I don't know if you can see that, but it's there. Oh, that's going to minimize. Okay, 4, 5, 6, 7. Let's just run it to here. We'll run through all probabilities, and now I can look at the probabilities. So the reason why we're choosing 8 is because our probability counter was 104. And for a 9, it was 100. So 8 is more than the 9. That's too bad. So the reason I think that we mistook the 9 for an 8 is because of this extra stuff here. Let's now look at the 2 and 7, because I think where's my the S. So let's have a look at the S and see if it's a similar issue with stuff on the left being mistaken for the actual digit in question. Okay, let's, instead of going on the Z, let's go to the S. We're going to put a breakpoint here. Okay, then we'll debug our test. So stuff on the left is slightly skewing that image. Okay, let's see if the 2 and the 7. So again, this is 3 digits we're looking at. The first 2 are 0. Oh, no. 0, 1, right. So the second digit is a 1. Now this third digit, let us do digit image dot save. Okay, so now we should be looking at the 2, and this is being mistaken for a 7. I kind of see why. Really, I do see why. Let's have a look at because I mean, it's clearly a nice shaped 7, but it's a 2. Why is this horizontal bit sort of being ignored? Okay, let's just debug to here, and we're gonna see. So the probability that it was a 2, our score was 77. And the probability that it's a 7 is 84. Interesting. So, like, again, it's quite interesting. So there's a few things we can tweak. And one of the things I'm going to tweak, and I want to be careful about this, because I still saw, like, there's still this bit here on the left that belongs to the 1. I think the whole window needs to shift to the right a bit. So what I'm going to do, that's the first thing I'm going to try, is we're going to go into our settings, and these are the positions of all of the positions on screen, right? And I'm going to increase the X value of all of these points to 1. Now the size of the box is determined by the algorithm as it currently stands. And my hope is that I can change that, because I don't want the algorithm. I was going to try and make it dynamic so different sized screenshots could be figured out, but I realize that's too complicated. And I might introduce some errors. So I want to simplify it, but we need this to work first. So instead of starting the box at pixel 149 on the horizontal for all of these piece counts, I've shifted it over to 150. Let's see what happens if we run this test. We're just going to run it. We're not going to debug it, and I want to see what's going on. So now that actually fixed our 2 issues, but we now have an additional. So we've traded off. We had 2 errors, and this fixed them both, but now we have an error in something else. I want to see what happens if I run it for everything. And then we'll make a decision about what we do next based on the result of that test. So let's not... Let's just cut that out. And again, we're skipping the first line in the CSV file because that was our header line. And those are just some values, or the names of the columns. Okay, let's try and run this and see what happens. This is our new, our new defined box count for, not box count, box position for the piece counts. And again, all these tests are going to pass because we're not actually making any assertions, because I don't want tests to prematurely fail. So we're just gathering a report. Okay, we're done. Let's see our report. What? Huh? No, I can't believe that. I refuse to believe that. That suggested there was only the one issue. That's not real. That was too good. That's a problem. Can't be too good. It did run all of these tests though. Okay, I'm going to clean the solution. That's going to remove okay, I'm actually deleting the data recognition report. It's not even there anymore. Okay, let's run these tests again. Surely there's more errors than just that one that we introduced. I mean, don't get me wrong, that would be fantastic, but I don't believe it. Not for a second. But then again, we only had 3 actual mistaken identities, right? So perhaps, okay, where's our report? I closed it. I'm going to have to find my report here. Oh my goodness. That's real. This is not fake. This is real. Seriously? Are you serious? Okay, let's open up 105. We're expecting the long bars to be 8, but we found 9. So this 8 is being mistaken for a 9. Look at that, it all just bleeds into each digit, eh? Okay, well let's debug this and see what the problem is. I mean, if this is real, this would be fantastic. So really, that doesn't speak to an error in the algorithm. It just speaks to an error in the positioning of the box. That's it. So maybe we have an incorrect y value or something for the I. Okay. Whoops. No, that was right. There we go. Here we go. So again, we're going to 105. Bring that back. Okay. And this time, our breakpoint is going here. Whoops. That was totally unexpected. All right. Oh, whoops. Yeah, right. Oops. I want it to go into, not continue. Okay. So this is the eye, the full width, the crop area, the sub-image. I want to actually take a look at the sub-image. This is the whole, oops, the entire image of the long bars. Pretty nicely spaced from what I can tell. Okay, so we're going to have 3 digits. The first one will be recognized as a 0. The second one will be recognized as a 0. And the third one just want to make sure. I don't see how you can get a more perfectly encased box than that. But it's certainly not a symmetrical 8 by any stretch of the imagination. Okay, let's get the probabilities. Actually, let's take a look at the reduced image because that could change. I mean, that will change. Because if you recall from 100 million years ago, the algorithm doesn't care about pixel color, just whether it's black or not. And dark enough pixels we consider black. So, and the reducing the image takes away all the black space around the image. It will remove some colored pixels if they're dark enough. Ugh. Yeah. I kind of see now why this is going to be mistaken for a 9. It's taken away too much. So this actually suffers. Let's get all the probabilities. Let's see how close it is. Oh, look at that, 104 to 105. Come on. It is so slight. Oh, come on, 1 pixel off? What else could I have done? I mean, the thing is, what I could have done is if I was moved over 1 more to the right, I think it would have discovered it. Let's try that. So right now I'm only running for 105. So I'm going to change. I'm going to move the box over one more for all of them because they all line up to the same X value. Okay, let's run this. And that's run. So we still have an issue. We still have an issue. But everything else still works. Did it... Is it better or is it worse? So now, interesting, it didn't really change at all. One of the things I want to do now let's run it for everything. We'll see that it's still working for the most part. Okay, we'll run it. We can watch it run in this window. And honestly, it could be that those red things just bleed into each other so much. What do we have? Still, that is the only issue. So what I'm thinking is because these things bleed into each other, the red piece counts, is we might have a different value of a black pixel for the red pieces as opposed to the white numbers in the score level and the line count. So what I want to do is sufficiently remove. I'm going to change what it means to be black. We have it at 130 now. I'm going to bump it up to 150. We'll go back to our extraction test. And we did this before, but we didn't really know what we were doing. We were just looking at numbers of errors. Now I want to see if changing it to 150 fixes the red, or the piece count. And if it does, we might actually change this to specify what it means to be a black pixel, that each method that calls the black pixel checker can define its own level of blackness. Huh. Didn't I change it to 1? That fixed it, and everything else is still working. Okay, let's bring back all of our tests once again. See, we did a few things. What's happening? Run the tests. There we go. We did a few things. The first time we had it at 150, we hadn't played with the positioning of the box. So I think now that we played with the positioning of the box and then went back to 150, it'll be a state that we've never tried before. Okay, so we're getting some issues. Some more issues. Oh, interesting. Expected 12, but you only found 2. 32 was mistaken for 82. 3s and 8s, again with the 9 and the 18 and the 9. But again, only with piece counts. Only with piece counts. And every single long bar was correct. I just want to check my time. I can't actually see the time on my screen. Okay, this has caused me to think that I should actually, now that we have these tests, let's merge them back into the main branch, the master branch, where we've started to refactor our algorithm, because I suspect some of these things are just tweaking values and might not have anything to do with the algorithm itself. So changing the box positioning, that's on the user of the program, not the algorithm. Changing the blackness of the pixel, we could actually customize to the red numbers or the white numbers. And then if we modify or refactor our algorithm to be simpler, we can probably fix these issues quicker. Because right now it's a delicate balance, which tweak this and all of these tests fail, and tweak that and other tests fail. We want to get something that will make all tests pass. And in preparation, if you saw my last video, I think, I made like 70 more screenshots that I'm going to enter into my CSV file, so we have a ridiculous amount of tests that we can run. But okay, I think we're going to stop it there. There's not a whole lot else I can do. Next time, actually, what we'll do before we end, let's make sure all of our tests. This is a good state that the test class is in. So what I'm going to do is some git magic here. This is in our main branch, or this is in our integration tests. Yeah. So I want to take integration tests because, is this a thing? Yeah, that's a thing. The history of our code. Oh, I want to view preferences. Forget it. Forget it. Okay. Oh, yes. Because if I look back, and if I go here, my master branch actually has... Okay, let's add all this stuff. Git status. We got these two things. This is adding integration tests, commits, finished integration tests. Okay, I'm going to throw this up to Bitbucket. That's fine. Now I'm going to check out my master branch, which these days you're not supposed to call your branch master because of political upheaval issues. So maybe I should rename that. Okay, the last thing I merged into here was refactoring, and now things are borked. Git log minus 2. So I'm gonna git merge no fast forward integration tests, and that is good. So now I have adding integration tests, finished integration tests, and that, where's my, yeah. So now I've got the refactoring I was doing in part 14, along with the new integration tests. So this is the latest version of the code along with the integration tests. And we can see that here because we had changed all of these methods into lazily loaded properties. And yeah, and it's this kind of stuff here I want to get rid of. All of this. I don't want any of that. My refactoring will simplify this a lot. And the hope is that once it's simple, it's easy to debug and fix, and then we'll be off to the races. So thanks for joining me. Have a great week, and we'll see you next time.